existing table. But now we can check. So let's just execute this. Okay, so now our trips variable data frame should now contain everything from beginning of September to end of October. And if you look at the minimum start time and the maximum start time, we can see we now have our data ranges from the 1st of September all the way to 31st of October. Okay, that's good. Okay, but so the big problem so far was always that we had these stations, and they were just these identifiers, abstract identifiers. So it would be much more interesting now if we could actually give names and maybe GPS positions for all of these stations, that we can plot them in a nice way. And luckily, the data is available. It's in JSON format. So I've downloaded it here. And then if you print it out, you get this type of data. So essentially, this is JSON, which is, think of it as a Python dictionary. So essentially, we have stations pop attribute here. That is a list. And then for each station, we have the ID. And then we have data like if it's in service, the title of that station, the number of logs that the station has, and the GPS coordinates of that station. Okay, so that's exactly what we're looking for. So let's try and read this in. So the first obvious natural choice would be to simply use the pd.readJSON data function to read in that file. But unfortunately, this doesn't work out of the box because Pandas expects a specific structure of the JSON to read it in. So then if you're in a situation like this, then you need to read in the JSON manually. So there's a JSON module that I used here. So I used the JSON.load function, providing the file name. And then let's see what it looks like. So this actually succeeds. And yeah, we get the same data that I just showed you, just as a Python data structure. And this is now a dictionary. So you can see that the data that we're actually interested in is this ID, and then probably the GPS coordinates and the number of logs. So what we can do is we can extract this. This is kind of a nested dictionary. You can extract this station attribute out there. This is what I've done here. So I just write station JSON equals JSON stations, just this component. So now what I have is I have a list of stations and all the station metadata. Okay, and so now the next step is that you pass that into the function JSON normalize, which takes in a JSON object and it converts it into a Pandas compatible format. Okay, and then this is what we get. So now we have a Pandas data frame with the station information. We have the station ID as a column, in service, if it's in service or not, as a column, the title, number of logs, and then also importantly the GPS coordinates. So now is a good moment to think about what these indices are. At the moment, Pandas decided to create its own index, but in this case, it seems very natural to use actually the station ID as an index, right? So there's no double indexing necessary. This is useful, for instance, when we do plotting, but it's also for performance reasons. It's a good idea to set these indices. So the way you do that is you use the setIndex function. You can do that on existing data frame. And then you specify the column that you want to have used as an index. And you can see that the output is the same data frame, but the ID column was now removed, but instead it is used as an index column. And otherwise, it's the same still. So yeah, where is this used? For instance, when you plot, by default, on the x-axis, it uses now the station IDs instead of this indexing from 0. So then the next important part is kind of to throw away data that we're not interested in, right? There's a lot of columns that we didn't actually want to, or that we're not interested in. You can use the top function, and you simply provide the column names in the list that you're not interested in. So in our case, there was this bounds and the subtitle, for instance, that we don't really care about. I should also mention that there's the axis argument that tells you if you want to throw away columns or rows. If you set it to 1, you want to throw away columns, which we want to do in this case. So now I've cleaned up the columns that I'm not interested in, and this is essentially the data that I really want to keep. Of course, alternatively, you could have also used the .log function to create a view on an existing data frame to extract the subset of the data that you're interested in. So then, often it's useful to compute additional columns based on the existing columns. This could be, to give you a concrete example, for these stations, let's say we want to generate an additional column that tells us how far is that station away from the center of Oslo. Okay, so that's an additional data information for each station. So we add that we need another column. And the way you do that is you use the apply function on the data frame, and you pass in as an argument the function that you want that computes the value of interest. And again, this can be if it's supposed to be a new column or new row. So in our case, I want to create a new column. Okay, so I created a function that computes the distance to the Oslo center. So it takes in one row or one station, and it extracts the center latitude and center longitude. So these were the column names for the lat and longitude. And then I do some maths calculation to figure out how big the distance is. Okay, and then I call the stations.apply method. And then what you get out is you get a one-dimensional series that contains the station ID as index and then the distance as value. And then we can add that series to our data frame. So I simply do an assignment here, name of column, and then the data series. And then our resulting new data frame now contains the original columns plus the computed column. Okay, so then often it's also useful to create some very simple statistics like the minimum, maximum, or mean of a column. So simply call these methods on the column. So if you want to get the minimum number of logs, stations number of logs.min, which is 6, and then you can get the maximum number, which is see how big that is, 48, and then the mean is 22 logs. So this computes values from an entire column, and it reduces to a single number. And you can also select rows based on specific conditions. So if you're interested in stations that have at least 40 logs, you can use the square bracket notation, and then inside that bracket you specify the condition that you want to have satisfied. So that way you get a sub-selection of data that satisfies the condition. Okay, but now, of course, once we have the stations, the next interesting part is to actually plot them where they are. So now comes some matplotlib magic. This is actually, I changed this to OpenStreetMap. So I created a screenshot of an OpenStreetMap map from Oslo and saved in oslo.png. So yeah. So essentially, maybe I show you the result first. So this is the script that generates the a map of Oslo, a bit squeezed, and then the blue dots represent the locations of the stations based on the Pandas JSON data frame. So let's see how that works. So I import matplotlib first. Then I read an image that I want to. This is going to be the background image, which is going to be the map here. And then I create a new subfigure. This is not strictly necessary, but I get the figures and the axes, and I want to get hold on these objects that I have a bit more control. So then on the axis, I create a scatter plot with a station. So here now I use the Pandas data frame to extract the longitude and the latitude. So I create a scatter plot, which essentially adds the points inside that image. Then I also add the image, the background image to that figure. So I use image show for that. And then I finally set the title and specify the bounding boxes. Okay, and then you get a nice picture of the locations of the bike stations. Okay, so now the next step is to merge the two tables that we loaded in. So we have one table with the trips, and we have one table with the stations, and now we want to have one merged table that contains both. So the problem is at the moment, if you look at the trips, is that the start station is simply these abstract IDs, and the end station the same. So what we want to do is we want to have one big table that contains the start station, but also ID, but also all the information about the start station, like the GPS and the name. So there's a method called merge that does that, and it's a bit involved. So I'm going to go through it step by step. So what you need to do is the merge takes two data frames in. One is called left and one is called right. Okay, these are going, and the result is a merged version of these two data frames. And the how, you can just ignore for a second. But the last two arguments here, they specify on how these two tables should be merged. And for both this left on and right on, you need to provide a column name that will be used as a common identifier to merge these. So I think the best way actually to explain this to you is through a very simple demo here. So imagine you have two data frames. One is called purchases, which contains some, let's just print them out what they look like. Okay, imagine you have two data frames. One is called purchases and one is called prices. In both cases, you have some products, and then in the first table, it specifies how often that product was bought. In the second table, it tells you the price of each product. And our task is now to merge these two tables. Okay? So when we use this merge command, we need to provide the name of the two tables. The first one is so I call pd.merge. I specify the purchase table and the prices table. And then I also need to specify which column should be used to identify which row belongs from one table belongs to the row of the other table. Right? And in this case, they're both on the left column, on the left data frame, I want to use the product column. And on the right data frame, I also want to use the product column. But in this case, they're called the same. But in principle, they might have different names. And then I need to specify the names of the different columns. And so now, exactly. So now what happens is that the result will be, I'm just going to change this to outer for a second, so you see the result. So now the result is that we have a new table that is the merge of the first two. And you see the first row here is apples, and the value of the purchases was 1, and the price is 5.5, because we used the product column as a common index for the two. So that's how it was matched. Okay? So in oranges is another example. Oranges shows up 3 here, but we don't actually have a price for values. So then here it was just filled out with a none. And the same with pears. So for pears, we have a price, but we didn't have any data for purchases. So it ends up with a none here. Okay, does it make sense so far? Yeah? So now comes the last argument, this how. And the how argument specifies what should be done in cases where you have data in one table but no data in the other table. Okay? And you essentially have 4 different choices. You can say inner, and when you choose inner, then you only get the data where you have information from both tables. In this case, it's only apples. Then you have outer. In outer, you always get all the data from both tables, and if no data is available, then it just extended with nonce. And then you have left. So when you choose left, then you always get the data from the left data frame. And if information is missing on the right data frame, then it's filled out with none. But in this case, you can see that pairs is missing in the output because we only care about the left table. And the last one is right, which is exactly the opposite. So then you always get the data from the right table, but you might miss some data from the left table. So if you visualize that, this is visualized here in these 4 pictures. So if you use inner, you only get the intersection. If you go outer, then you get everything, and then left and right is the different sides respectively. So this is if you know about database programming, this is also known as joins. So it's a concept that is quite important also in other areas. So, but now if we go back to our bike examples, so we have the trips and we have the stations, right? And now we need to figure out the merge command that we're interested in. And so let's see. So let's first do the start station, right? So clearly, first we need to figure out these indices that we want to match. And well, for the left table, which is going to be this one, the trips, it's going to be the start station. That's a station index. And then for the stations, we actually want to have the index of the table, because we set the index for that one. So the merge command will be, I call pd.merge. I provide the trips at the left table, the stations at the right table. And now I need to decide how I want to do it. So I care I don't care about keeping all the stations, right? There might be stations, there might be one station that was never used in a trip, but I don't mind losing that one. But I do care that I keep all the trips. I just want to expand, I just want to add more information to the trips table. So therefore, I choose left here. Okay? And then on the left index that I want to merge is the start station. And then for the right index, I use the index of the data table as a matching index. Does it make sense? I show you the result. So now, in the resulting table, we have all the columns of the trips. So start time, start station, end time. And then in addition, we have all the information about that station. And here I need to specify, it's the start station information that we added here, right? So the start station here was the St. Hans-Haugen Park, has 15 logs, and so on. And now we can check that we can check the length of the merged table with the length of the original table, and they should be exactly the same because we shouldn't have changed the number of trips by just adding the information. So that is kind of just a sanity check. And now we can do exactly the same for the end station. And so I had another merge command. And so now you can see I have the left. I now use for the left one, for the left column, I use the end station. And I also add indices to separate the information for the start and the end station. So you can see that that is being added to the column names. So now you can see here all the column names for the end station has the suffix end, while all the columns for the start station have the suffix start, so that we can separate them because they have exactly the same column names. Yeah. Okay, so now we have quite a complex table with all the information that that we're interested in. Okay, so now we can do the same. Now we can do the same analysis, but this time we can actually figure out the names of the stations, which is a lot more interesting, right? So I can, for instance, extract the busiest stations. Again, I use this value counts here. So this gives me the indices of the busiest stations, and then I can use the log function to just to print these out. So here we see, so here we actually don't make use of this merged data frame. But here we can see, okay, the most used station was Alexander Schillensplatz, Bischofs Stadion, and so on. And of course, we also see the distance to Oslo Center. So that was our computed column. Okay. So let's see, I don't think I didn't want to go through this. No, I don't think I'm going to go through this. So, do we have any questions? No? Are you ready to do some data analysis from next week? Yeah? Maybe just one comment. We started to correct the assignments, or we are hopefully done by the end of this week. And you've done the peer reviews really, really nicely. But I think one area where we can improve is the comment section where you submit the peer reviews. So quite often this was there was not much information. You know, when you submit the pull request, then you have a text box where you can add a comment. And I think we can work on that and improve that a bit for the future assignment. So I will prepare a better solution for that, or I want to show you kind of a reference comment for this pull request, so that hopefully you can learn from that. Yeah. Okay, are there any questions otherwise? No? Then see you next week.